We are starting with the 7th chapter now, which is deep learning research. So, till now we have seen what is supervised learning and how we have studied different supervised learning algorithms also. But you have to understand that if you need good accuracy in supervised learning algorithms, you need to have a good amount of label data. Every time in real world situations, it is not possible that you get that good amount of label data. So many times when the label data is available, supervised learning cannot be performed because जितना ज़्यादा अच्छा लेबल डेटा होगा उतना अच्छा सुपरवाइज लर्निंग का रिजल्ट्स होगा. सो जब आपके पास लेबल डेटा नहीं है, देन हु कैन हेल्प यू? So then obviously unsupervised learning will help you. Okay, so you have to understand that the problem domains in which we use supervised learning and the problem domains in which we use unsupervised learning are different. You cannot compare that. कि ये सुपरवाइज लर्निंग का प्रॉब्लम था, अभी उसको कन्वर्ट करके अनसुपरवाइज लर्निंग में लेकर आओ. ये ऐसा हर बार पॉसिबल नहीं होने वाला है. बट जब आपके पास लेबल डेटा है ही नहीं, तो यू डोंट हैव अ सॉल्यूशन. The only thing you can do is you can use unsupervised learning. Okay, so and that's the reason we are learning unsupervised learning. So unsupervised learning में basically high dimensionality एक बहुत बड़ा प्रॉब्लम होता है. जब डेटा का डायमेंशनैलिटी हाई होता है तो कंप्यूटेशंस ज़्यादा लगते हैं, स्टैटिस्टिकल कैलकुलेशन ज़्यादा लगते हैं. सो इन सारी चीज़ों में कॉम्प्लेक्सिटी आने लगती है. सो इट बिकम्स necessary that you understand different unsupervised learning approaches and you also understand how these approaches will tackle the high dimensionality of the problem. So we are going to study many such approaches today. So the very first one is linear factor model. So linear factor model basically क्या करता है? ये probabilistic model है. So you have to understand that I had told you something which is called as deterministic and approximate. So we are not looking at a deterministic model, we are looking at a probabilistic model which will give you an approximate inference of something. Okay, it may not be an exact inference of something, but it will give you an approximate inference of something. Okay, so linear factor model is a probabilistic model where we are obtaining x. X is something that we wish to identify, okay, or that we wish to calculate by using linear decoder function. Now this linear decoder function is created by combining the linear transformation with the noise. Now how is the linear transformation denoted? It is denoted by WH plus B. Okay, so W, we all know it is a weight matrix. H is nothing but your latent variable. Please remember, latent variable is a variable that is not directly calculated, but it can be observed or calculated indirectly. Okay, B is a bias, and the noise factor is generally a normally distributed noise or a diagonal noise. Okay, so in linear factor model, H is also called as an explanatory factor which is obtained from some factorial distribution. Okay, you can see the formula over here. H is approximately equal to P of H, where P of H is calculated using this formula. You can see the bigger pi sign over there. It typically indicates multiplication of all the terms. Okay, whatever i's you are going to have, उन सब सारे टर्म्स का मल्टीप्लिकेशन विल गिव यू P of H. Okay, and we are assuming that all HIs are independent. If I have to show the things diagrammatically, I'll show it like this: x1, x2, x3 and h1, h2, h3. Okay, x are called as observed variables which are obtained from hidden variables HI. Next we are going to see something which is called as principal component analysis, factor analysis and independent component analysis models. Now these models are typically variations of your linear factor model, जहाँ पे noise और distribution of latent variable अलग अलग होता है. Now we are going to first study what is probabilistic PCA. तो सबसे पहले ये समझ लो कि PCA क्या है, Principal Component Analysis. Whenever we want to go ahead with something that is called as dimensionality reduction, PCA is one of the technique that is used for that. But जब हम लोग deterministically करते हैं चीज़ें तो उसको PCA बोला जाता है. बट जब हम लोग डिटर्मिनिस्टिक वाला पार्ट उसमें से हटा देते, वी गो अहेड विद द अप्रोक्सीमेट इन्फरेंस काइंड ऑफ थिंग, जब देन इट इज कॉल्ड एज प्रोबेबिलिस्टिक पीसीए. ओके, सो PCA is a popular technique that is used in variable selection. I told you it is used for dimensionality reduction. So मेरे पास अगर 15 वेरिएबल्स है, उसमें से ऐसे कौन से वेरिएबल्स है जो सबसे ज्यादा सेट ऑफ इंफॉर्मेशन कन्वे करते हैं. सो आई हैव टू चूज दैट. देन आई विल बी यूजिंग प्रिंसिपल कंपोनेंट एनालिसिस. सो इट अलाउज अस टू रिड्यूस द डायमेंशंस टू वर्क विथ. Okay, we all know that variance corresponds to information. So in the process of PCA हम लोग ऐसे वेक्टर्स चूज करते हैं जो हम लोग को मैक्सिमम वेरिएंस देता है. ओके, एंड देन वी कीप ऑन रिपीटिंग इट टिल वी फाइंड वेक्टर्स इक्वल टू द डायमेंशंस ऑफ द डेटा सेट. And we will select m vectors or accesses for the data set with dimension d such that m is less than d. So in short we have got m accesses that store maximum information because जितना ज़्यादा variance उतना ज़्यादा information वो store करेगा. Okay, but अभी normal PCA क्यों नहीं use करना है? PCA is, yes it is used for dimensionality reduction, but normal PCA के साथ problem ये होता है कि it does not allow us to capture information if the relationships are non-linear. ओके, इसलिए फिर प्रोबेबिलिस्टिक पीसीए आ जाता है, where most variations in the data can be captured by latent variables with the residual error sigma square, and as sigma square tends to 0 the probabilistic PCA does become normal PCA. Okay, abhi in probabilistic PCA the noise which is considered, it is generally considered to be drawn from diagonal covariance Gaussian distribution, and the covariance matrix is given as this. Okay, and you can see this is how we represent the variance vector. Okay, now H is going to capture the dependencies between variable x. So as you can see in this formula, H is nothing but your random vector. N, it denotes normal or Gaussian distribution. O is the mean of vector distribution. Okay, and I is nothing but the covariance matrix of the distribution. And your formula becomes X is equal to WH plus B plus sigma Z, where Z is nothing but your Gaussian noise. Now we go ahead with another term which is called as factor analysis. Factor analysis typically focuses on locating independent variables. So H is again unit variance Gaussian, and X variable is supposed to be conditionally dependent such as H is given. So factor analysis में जो noise consider होता है वो होता है diagonal Gaussian distribution noise. And again the covariance matrix is given as it is shown over here. Okay, and the meaning of H, X and the related terms, it remains the same. The difference that you can see is in this formula. Okay, this particular formula for PCA was different, and for factor analysis it is different. Now we then come to something which is called as independent component analysis. What is independent component analysis? Let us understand the use case of ICA first, and then we will go on to the explanation part. Let's say I have a voice recording where the 3-4 people are speaking. What I want to do is I want to separate the speech of every single person. So person number what he is speaking, person number 2 what he or she is speaking, person number 3 what he or she is speaking. If I need to do that, then I will be using ICA. So ICA typically deals with separating and observed signals into underlying signals, which can be scaled or which can be added together to form your observed data. Okay, and we are assuming that these signals are independent. Okay, so the exact same use case is discussed over here, which I give you. If I want to separate the speech signals of people talking simultaneously, this is what I will be doing. In this model, the prior distribution H from which H is generated is fixed. Okay, so X is equal to WH becomes your formula. And if you want to train this model, you can train this model using maximum likelihood. P of H is independent, and then we can obtain underlying factors that are likely to be independent. Exactly same example is explained over here. You can see how the formula is given. P of S1 comma S2, and it is given as pi. I told you what this pi means. It simply means product of the probability density functions P of Si. Okay, where I value ranges from 1 to n. Summation का मतलब होता है sum या addition. जब ऐसे बड़ा वाला पाई दिखता है आपको, उसका मतलब होता है it is product. In all these three, you have to understand that purpose of every method is different. Especially factor analysis. Factor analysis इसलिए किया जाता है कि हमें पता चले ऐसे कौन से factors है जिसके वजह से there is some kind of decision made or which results into some kind of correlation in your output. The next concept we have on the same lines is slow feature analysis. Slow feature analysis is based on slowness principle. Okay, and it can be applied to any model that is trained with gradient descent. We already know what gradient descent is. Okay, अभी slow feature analysis में information is extracted from time signals. अभी obviously it is an unsupervised learning technique, and इसमें होता क्या है? The name itself will tell you. I want to figure out or extract the features which are varying slowly as opposed to the features which are varying quickly. अभी एक simple example ले लो. There is a video which is running and you are able to see that a zebra is moving from left hand side of the screen to the right hand side of the screen. अभी individual pixel है, वो black से white होगा, white से black होगा, तो वो जैसे zebra का strip pass होता है from that pixel, उसका कलर चेंज होते जाएगा. सो जेब्रा मूविंग या वो पिक्सल व्हाइट से ब्लैक हो रहा है, ब्लैक से व्हाइट हो रहा है, इज अ क्विकली वैरिंग सिग्नल. बट जेब्रा का जो पोजीशन है वो स्लोली चेंज हो रहा है. सो स्लो फीचर एनालिसिस में हम लोग को ऐसे चीजें देखनी है या ऐसे फीचर्स एक्सट्रैक्ट करने हैं जो स्लोली वैरिंग है. फास्ट वैरिंग फीचर्स या क्विकली वैरिंग फीचर्स को हमें इग्नोर करना है. सो आई हैव टू check a feature कि whether the zebra is there in the image or no. So feature describing the zebra's position is slowly changing. Even though the pixels are rapidly changing, the feature which is describing the zebra's position on the screen is slowly changing. So that is the basic concept of slow feature analysis. This particular analysis is quite efficient because it is used in linear feature extractor, and it is possible to theoretically predict the feature SFA will learn. So we can predict what kind of features we want SFA to work with. Now we go ahead to something which is called as sparse coding. Sparse coding again is a class of unsupervised learning algorithms. And the main aim over here is to represent the data efficiently. So this is mostly used in linear factor models from unsupervised feature learning, and it helps deciding the value of a latent variable in the model. So you have to understand that not every variable is equally important, and आपको ये पता करना ज़रूरी है कि कौन सा variable कितना अच्छे से data को represent कर सकता है. In this model, X is obtained using decoder and reconstructions, which is given over here. We all know W is a weight matrix, H is your latent variables, B is bias, and N is noise. We are considering Gaussian noise with isotropic precision beta, and probability of Hx is given like this. Okay. So isotropic noise is basically a noise जिसका intensity is equal in all your directions. Okay, and उसको uniform statistical properties होते हैं for every orientation. So that is called as isotopic. Isotopic basically means same in all the directions. ऊपर हम लोग ने जो देखा था कि n0 sigma square I. So n is basically, as I told you then also, it is a normal distribution. And when you see 0 there, it typically means कि the mean is 0. And sigma square I is nothing but the identity matrix. So sigma square I becomes your covariance matrix for that particular noise. So that is the meaning of isotopic noise. So now let us go ahead to the next concept, which is called as manifold interpretation of PCA. Before going to that, we have to understand what is called as manifold. So manifold is a basic concept जहाँ पे हम लोग ये सोचते हैं कि a lower dimension space is embedded in a higher dimension space, and your actual data will lie in this lower dimensional space. When you think of PCA and some concepts like that, हम लोग ये assume करते हैं कि data lies in a flat linear subspace, and manifold learning में हम लोग ये कहते हैं कि ज़रूरी नहीं है कि वो flat surface ही हो, वो एक curved surface भी हो सकता है. Okay, so here if you see the last line, PCA can be interpreted as aligning this pancake with a linear manifold in a higher dimension space. So they have given you an example saying that कि अगर आपका जो बहुत बड़ा dimensionality है आपके पास, उसमें you can consider that manifold as a pancake. So that is what they have given you as an analogy. Okay. So let us go ahead and read what this says. We know that कि principal component analysis will help you in dimensionality reduction, but problem कब आता है जब आपका relationship non-linear होता है. तो जब non-linear relationship होता है, the basic PCA cannot handle it. Okay, इसीलिए फिर we come across with a concept which is called as manifold learning. Manifold learning, as I told you earlier, ये क्या कहता है? It describes the high dimensional data sets into the low dimensional manifolds. So probabilistic PCA can be viewed as a region of a shape of a thin pancake with high probability. Okay, and now your PCA can be interpreted as aligning this pancake with a linear manifold in higher dimensional space.